Bill Nye the Physics Guy. Bill Nye the Physics Guy. Will. This program is sponsored by Physics. If we didn't make a book, you wouldn't have a physics class.
Imagine this. One apple, but due to time and budget constraints, this is actually a clementine, but one apple is what helped Isaac Newton find the 3 laws of physics. And that is what we're going to be talking about tonight. As me and a bunch of my very special helpers, we will explain all 3 of them in easy, basic examples. So without further ado, here's the show. To explain Newton's first law, we're going to take a bit of a drive. So as I'm in the car, traveling 60 miles an hour, I'm going 60 miles an hour along with the car. So then all of a sudden, I'm on the highway, and all of a sudden, oh my God! Wow! And I can't stop because I just can't stop. And because he's such a vamp, when I hit into him, I hit into him. He doesn't hit into us. So what happens is the car gets damaged and stops. But the thing is, I don't stop because I'm a moron and
not wearing my seatbelt.
So what happens is I will fly through this windshield and I'll be covered in blood and my chunks of brain will be all over the road. And that's why, kids, wear a seatbelt.
Who is Isaac Newton? Newton was born on Christmas of 1642 and then died at March 20th, 1727 at the age of 84. He was an English physicist and mathematician who excelled in the fields of physics, philosophy, astronomy, alchemy, and economics. The reason why his 3 laws are so important is because they are the groundwork for physics today. The first law of physics is an object at rest stays at rest, and an object in motion continues in motion with constant velocity unless the object experiences a net external force. The second law states the acceleration of an object is directly proportional to the net external force acting on the object and inversely proportional to the object's mass. And then the final law is for every action there is an equal and opposite reaction.
What do you know about the victim?
He was a 14-year-old ninth grader.
Friends say he was heading to Myth nightclub, and I quote, to get fresh for a party. Looks like he was sending a tweet before he got hit.
What does the tweet say?
Crossing the street without looking both ways. Hashtag YOLO?
YOLO?
YOLO. What do you think happened?
Well, as Newton's first law states, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an outside force.
For our next example, we have our volunteers, Dane and Kenny, and what they're going to do is going to have a little tug of war battle. The reason why they're a stalemate like this is because both Dane and Kenny are similar height and weight. So what that means is because they're both pulling back, they cancel each other out. So now what happens is if I do my own brawn with Dane, we pull Kenny all the way back, because with those stalemate and then you add me, he's gone. And that's how you win tug of war. Professional sports players strive to be the biggest, the fastest, and the best. A prime example here is none other than Adrian Peterson, as he is 6'1" and 220 pounds. As you can see here, he is running over the cornerback for the Pittsburgh Steelers, William Gay. And with second law, even though he is much bigger than the 170-pound cornerback for the Steelers, because of the acceleration he gained during months and months of training, he is able to run over him and get a first down. And that is why Adrian Peterson is such a great football player.
Second law is usually illustrated by the equation force equals mass times acceleration, and a demonstration of this is if you put a toothpick on a washcloth here, and with very little force you're able to carry it with like a lot of acceleration, but if you put this remote control on it, you have to put a lot more force into it to have the same amount of acceleration because of the increased mass.
Alright, for another example, we have Jake and this ball. What I'm going to have Jake do is going to throw that ball at the wall. The reason why I have him throwing the ball at the wall is because when he throws it, he enacts a force on the ball that goes all the way to the wall. Because the wall has a much larger mass, it will be able to bounce the ball back because it's nothing to the wall. And then if he kept doing this for, I don't know, millions of years, it'd eventually break down the wall. And that's how Newton's third law works.
That's pretty neat. Damn wall! What
are you doing?
Trying to move this wall.
You don't know much about Newton's third law of motion, do you?
What's that?
For every action, there's an opposite and equal reaction.
Oh. Oh. Well, that's pretty neat.
Yeah, it is. Since there's more mass, with this you need a lot of force to push it, and since you're not generating enough force, you're not pushing it.
Oh. Want to help me push the wall?
Yes.
Well, that's tonight's episode. If you need any more information on physics, use Holt Physics for your physics help needs, or ask your physics teacher, Mr. UR. I'm Bill Nye. Good night.
Quote, she said, freshen up for the...
No!
Whip.
Fight. That's cheating. A demonstration of the second law of motion is
I'm a moron and I'm wearing my seatbelt.